Before I talk about my small 1 1/4 acre project in Jack London State Park, I'll tell you how this came about. It's because of our solid waste cleanup program, deeply embedded in the Integrated Waste Management Board, created back in 1994 with Assembly Bill 2136. And we get about $5 million per year into our solid waste cleanup program trust fund to clean up sites around the state that are a problem with public health and safety or the environment, and for which we have no responsible party that is willing or able to clean up the site. We get a lot of our information of these sites from internally generated reports and people, and we get them from the LEAs, and we get them from sister state agencies and local governments. So we, in the past, since 1994, we have cleaned up 590 illegal disposal sites and burn dumps and other types of solid waste sites, and we've spent $52 million. And we've also generated some $37 million of associated money from partners, and we've also received about $7 million back in cost recovery. So on to my Sonoma Developmental Center cleanup in the Jack London State Park. In 2002, we were requested by the Department of Park and Recreation and the Sonoma Developmental Center to consider this project. We did a site investigation in 2002 and found it had RCRA hazardous waste, California hazardous waste, and some non-hazardous waste, about 1,500 yards of it over about an acre and 1/4. We got approval from the Waste Management Board to clean this project up in May 2003. We studied for a year to figure out how to clean it up, and you'll see why we had to study for a year how to clean it up shortly. We were trying to figure out how to get to the waste, whether we should leave it on site or clean it up. So after a year, we figured it out, and it took us 4 months to design, to fabricate some material that had to be done ahead of time and do the project. And with that, I'll show you a little picture or two of what's happening. The Sonoma Developmental Center, of course, generated this waste through their local residents in that center and from their hospital. And in 2002, about 600 acres was transferred from Sonoma Developmental Center to state parks and became part of the Jack London Park. That one little parcel was going to be turned back in case it didn't get cleaned up. Conditions prior to cleanup, canyon slopes were too steep for normal access. I'm talking about a 67-degree slope. You couldn't walk on it without being tied to a rope. It was very difficult to access. Most of the waste was located about between 60 and 270 feet downhill. The road above it was collapsed from a previous effort in 1996 to remove waste. A large excavator kind of collapsed, and it was limited to light vehicles. We couldn't use it as it was. The waste was commingled with non-hazardous waste and cans, every other thing, and lots of rattlesnakes. Hundreds of rattlesnakes used it for a nesting area. It's kind of difficult to get down there. The road, as I said, was in disrepair and not built to carry, or not capable of carrying the heavy equipment. And they had to use the road, so they used it for light vehicles. They had it for fire protection. They also had a camp upstream where they brought visitors of the disabled residents of the developmental center, and they visited with their relatives. This is a view of the conditions along the upper slopes, and you can see that person is having a great deal of difficulty of getting along there. That was during the site investigation phase. And this is a little glimpse of the waste on the lower slopes. Remember that the waste you see to the right is over 200 feet down from the road. So our goal was that we decided to remove the waste instead of leaving something that had to be maintained. Our goal was remove and dispose of it at the appropriate disposal facilities and to eliminate the hazards from the pile, reduce lead concentrations to acceptable levels. We decided acceptable level was 130 parts per million of TTLC because that's what the Office of Scientific Affairs says in the state says is acceptable for no problems. We were going to install an erosion control geomat on the slopes and HYDROSEED all the areas and repair the road from our operations. And we had to keep the road open during the project for emergency fire equipment. Task one, we decided to tear down the road to something solid and use it for a work platform from above. Understanding we considered a new road through other areas, that was kiboshed because we didn't want to do an environmental impact report for removal of all the trees. And besides, the state parks wasn't going to let us remove all the trees anyway. They finally told us that. So we dug down about 12 feet here to construct this work platform to solid ground and also to expand it so we could get heavier equipment up there, as you will see. Once we did that, we got up there and we got a long reach excavator to take out the recre-hazardous waste was located near the upper part. That was very fortunate. So we located that during the site investigation, had it staked, and we directly loaded that onto trucks and took it off to Kettleman Hills. Then task 3 was to get down to the material on the lower slopes. Well, during our design, we decided we had to fabricate a rail system to get down to the waste. And so we fabricated that before we started work, and we brought it on site. Now we had to assemble it. That was our first part of task 3. We had to assemble this little system. We had prefabricated rail sections. We put in place and had a little railroad ties and staked those to the side. And then we put a D7 and D6 dozer at the top, tethered with a big cable to our excavators that we put over the sides. What you see is an excavator at the bottom. It's about a 10,000-pound excavator. We had 2 of them. We had a 15,000-pounder, a 10,000-pounder, and a 7,500-pounder. We tried all of those with varying success, but this 10,000-pounder worked very well. And we have a little cart down there, and it's down there loading. Now, one of the things that was wonderful about using an excavator, we didn't have to use labor down at the bottom until later stages because the rattlesnakes, once we got digging around in there, they decided that they had other places they wanted to be. So they departed the area. This is a picture of the little rail car going up the hill, and you'll see a cable going up there. It goes up, it goes over a pulley on the ground into there's a dead man. We dug a dead man at the back, big 12-inch diameter concrete filled hole with an I-beam in it with a block on it. Turned the cable 90 degrees to a winch truck. And on command from below, the winch truck operator would bring the car up, from which we loaded it onto 50-ton off-road trucks and hauled it down to a staging area. This is a little picture of the rail sled. It shows loading it up. Guys giving the word to the winch truck operator, and up we come. Now that is about, we extended it on down another 40 or 50 feet down the road there. But you'll see that we extended, as we had to go down, we added more sections. And this had about 1.5 yards of material in it. And pretty nifty. I don't know how we dreamed this up, but it worked. This is we fabricated it all site, and when we got out to the site, we had to remodel it about 3 times before. So when we got up the top, we had to stop it, we had to untie it, we had to connect it to the 330 cat excavator at the top, and he will shortly lift it. And this cart has a bottom opening device that is cleverly pulled by the laborer at the bottom to release it, hopefully when it gets over the truck. And And off we go. See, this is such a minute thing with all the big things you've seen before, you probably aren't interested in this. 28,000 acres versus 1 acre, that's not much. This is not PhD type thing here. This is something we just, folks, a lot of this is deserving of the contractor who was Gwynn Construction out of Bakersfield. They had a lot of great ideas that they put into this. You see, they had to even set it on a railroad tie to close it, and then we put it back on the sled and send it back down for another trip. Anybody got a sights on a steep slope? I think we still have that in the yard at Bakersfield. Well, we had about 1,200 loads going up and down.
How many cubic yards total?
There's about 1.5 yards of trash max that you could put in it.
The total of the project?
The total yards
On the project?
was about 1,500 cubic yards, which was turning it into tons for disposal was about 608 tons of material. And speaking of the material, we had of the 608 tons, we had 47 tons of recro waste, which was the the T-clip if toxicity characteristic leaching procedure. It was lead, lead constituents, and we had about 150 cubic yards of non-hazardous waste we disposed of in local landfills, and we had the about 350 tons of California hazardous waste, which also went to Kettleman Hills. Well, after we got the bulk of the material cleaned up, we did confirmation sampling. Notice that he's tied to a rope, and he's doing his checks in various locations. And then after we did the confirmation sampling, we found pockets we had to clean up by hand, and we then would take the excavator and bring it up and load it onto the cart. And our cleanup goals were met. 130 milligrams per kilogram was our total lead, was our goal. And our average of 21 samples that we took were 45 milligrams per kilogram. Task 5, we had to stockpile and segregate the waste to the best that we could. We, when we found something and we didn't know what it was, or we knew, suspected it was hazardous, we separated that. This is an unseparated load of material that came. We took our 330 cat from up above and brought down, had a bucket on it with a thumb, and he shook it and segregated the finer stuff, which was mostly burn ash, into smaller piles, 100 cubic yards, and then we would take composite samples and determine the 100-yard pile and send it to the appropriate facility. Other than, you couldn't do it for every loader, you'd be there forever. This pile is cans and miscellaneous stuff that were not hazardous and were sent to local landfills. When we got rid of all the waste, we had to fix the slope, so we installed erosion control mat on the slopes. You'll notice that mat is pretty heavy-looking stuff. It is. On a 67-degree slope, you couldn't put normal erosion control matting because about the first episode of a rain or something like that, it'd all be at the bottom. So we had to devise, or we had to find erosion control mat that was galvanized steel, looked like a fence with a coating on it. But basically, that's what it is. Then we had to tie it to the ground. We put like 12 to 18-inch iron pins in the ground to, well, that's the hog ring right there. They're tying them together on that particular one. But we hammered into the ground so it would stay there. When we got through with that task, we then went on to our road repair. Number one was to reconstruct the road section immediately above. So we used the soil reinforcement system, which again was looked like fencing, doesn't it? Then we put several layers of this erosion control like material down and put it in layers of engineered soil and above it. And we brought it back up its 12 foot to its original height, and it had a capability to carry the fire equipment, 18,000 pound fire equipment across it. We also destroyed most of the road with the 50-ton off-road trucks going up and down the hill because the drainage wasn't too good on the road. We had a lot of soft spots, and during the course of coming up and down the road, we finally bought all the lime in the county and went out and mixed it with the soft spots, and we hardened the material up in short order, and so we could get our trucks across, and also to make it more permanent subgrade. That is right there. We're putting lime, mixing lime with wet soil. Now we're cleaning some ditches, which we did up on both sides all along. Then we decided we had to destroy the whole road and start all over again. So we brought in this huge piece of equipment, and it pulverized 6 inches, including the small layer of asphalt and 4 inches of material below it. This machine went 1.5 miles up one way and down the other way in one day, pulverizing the road. So then we regraded it, we compacted it, and we started putting our 2 inches of asphalt, 2 inches minimum. A lot of places it was 4 to 6 inches because of where we had soft spots before. We tried to build up a little extra thickness. Concrete, you can see there, it's about 4 or 5 inches thick in that particular location. When we got through with the road, we waited for, we finished this project in 3 months, 12-hour days, 5 days a week. And we came back in October and hydroseeded the disturbed areas, this and the staging area that we had below. And this last year, this is kind of what it looks like. Started work in April of 2005, and we completed the hydroseeding in October. 605 tons of weight. I said 608. We found 3 tons in an isolated place later of non-hazardous. We went back when we did the hydroseeding, brought in the contractor again, and took out 3 more tons of non-hazardous waste to make the people happy. It was about half mile from where our project was. We installed 4,500 square yards of erosion mat, 15,300 square yards of road repair, 3 acres of slopes, and the project, not quite $1 million. Thank you very much.